let's give more, I to say, a more clear example how it should work in ideal world, because what we are looking for here, because okay, I've been reading on X a few funny stories how people see the developers work. The developer he sits at the desktop and they have number of Windows tabs opened. One tab is ChatGPT, another one is Cloud Gemini 2.5 Pro, another one. Okay, so you name it. And every model receives the same prompt, which then he basically copy pastes this Python script that the model generated, put it into run it, and which works better, he goes with this result. This is how people basically understand vibe coding. But how it works in reality, how it should work, and what people can expect if they use a tool like Autonomy AI that you create, there are clearly misconceptions. Help us understand it better how it should work.
So you beautifully you described vibe coding. As a company, we're trying to push everybody to do vibe engineering, as we call it, which means there's kind of a big gap between, let's say, someone just finished their computer science degree and they're starting their first job as a developer. They can write code, but it's very different from someone who's a senior who's been there for 15 years, who's a real software engineer. And we're very explicitly using the word engineer. Maintainable code is not just code that runs, it's code that's modular, it's consistently dry, don't repeat yourself, reuses components. If I want to change something tomorrow, it's really easy to change that thing. It'll propagate accordingly, and it's not spaghetti code that I'm going to spend, I don't know, a small change is going to take me days to test to make sure it didn't break anything. And there's best practices for that, right? Testing is kind of an obvious one. But if you tell, when you're vibe coding, or we're trying to push it more to vibe engineering, if you're saying, don't write the code. First, we're going to figure out the test cases. Let's write all the test cases. We're going more for test-driven development. So my vibe engineering workflow is, okay, we're going to talk about the testing. We're going to define all the test cases. Now we have code for that. Now let's go ahead and implement it. And in that way, when you do the work, also make a script that runs all the tests that we built. And in the future, when I'm asking you to change more and more things as an LLM, and you're going to touch so many things, some that I meant for you to touch, some that I didn't mean for you to touch, well, that test is always going to run. And I'm always, of course, going to be adding more tests as I go. And I'll have a way to make it less prone to regressions. Right? As the LLM touches something I didn't mean to, at least the tests will catch it. We're just talking about one part of it. There's more to vibe engineering, but that's at least one part of it, where you can have consistent results and have it be more resistant to regressions.
I see. Okay, but I still have question. For example, I can imagine two, let's say, edge cases, and let's contrast two prompts. For example, one, even if I am an experienced engineer and I know precisely what I need from my code and from my product, and I say generate a Next.js page that shows, okay, let's for example, we are working on a health device or something like that, and one prompt for me is generate a Next.js page that shows heart rate zones with a start and stop button, for example, because I understand what I want from that. Another example would be, I am training for a marathon, and during intervals, I want real-time zone feedback or post-workout recovery stats on my body, and a way to share progress with, for example, my coach, my peers, and I need data privacy. That's another prompt. And prompt B, for me, it seeds a product narrative, outcomes, constraints, stakeholders. Prompt A, on the other hand, it yields runnable code. So my hunch is that sustainable engineering emerges when we embed product context into the prompt. Right? And from what you've seen so far, like, how do successful teams write their code? Do they still write traditional design documents, or do you want them to do that? Or should they have or maybe they have merged that intent into outcome first prompts and let the agent trace implementation details? where is this line between storytelling and spec writing in this new world, how you imagine it?
Okay. First of all, beautiful question. That's exactly kind of the gap that the people are falling at. Let's take scenario A. So in that first prompt, you're just saying create the code. Here's the ticket scope, if we can name it that.
Yeah.
And there's a lot of stuff that you didn't include in that scope, right? Because you know how you're going to implement it, but for the LM to do a great job, there's a bunch of the set like
Yeah,
product.
basically LLM works in vacuum.
Yeah. And it's gonna you have a bunch of stuff that you're not mentioning because it's obvious to you. And you don't even realize that you need to mention because it's so obvious to you. But the LM doesn't know it. So when it does the work, it'll do some variations of the work, but not exactly what you meant. The right way to do that, for example, is not, okay, here it is, do the code. It's here it is. Let's consider all the edge cases that I didn't define here. And let's work on creating a better scope ticket together. And then you do that interaction with the LLM. In the end, you get that the ticket, or not the ticket, frankly, the context that the LM has to look at when it actually goes to do the task is much richer. Because you do a few interactions, it tells you the edge cases it can think of. You mentioned edge cases you can think of. You explain the behavior you wanted to take here and here. And only then, when you have kind of a pretty serious context, do you tell it, now do the code. And then it can finally understand all those hidden elements that were maybe obvious to you, but not obvious to it. And that ties beautifully into kind of the prompt B that you mentioned. Well, there you're saying, this is the behavior I want from product level, and that automatically answers a lot of those questions that were unknown in prompt A. So by giving it the product level perspective on the task that you're trying to do, it can have a much better time kind of guessing behavior at edge case that it runs into and implements in the code, understanding what you actually meant. That's something that we're addressing as a company by working on agents right now that face products, not just developers. So we're saying, okay, as a product, you're going to give a ticket that's eventually going to go to a developer and maybe along the way to an AI agent. In our case, we want to always go through an AI agent. But how can we make sure that that ticket is scoped, detailed enough that when a human reads it, it's fine. The human has a bunch of knowledge and a bunch of context and can make those logical jumps where something's not mentioned. But the AI agent, the LLM, when it reads it, it doesn't have that context. Not necessarily, at least. And you don't want it to be guessing stuff that you know how you want it to behave. So that's where the gap is. And that's why B works so much better.
All right, but who is the person who, because when it comes to product design, we have product designers and then we have developers. Who is this person who should start working with this agent? Because what would be the best practice? Describe goals and then accept that the agent picks the tools. And this is where basically, I don't know, maybe product designers' jobs is done, and then it forwards it to the developers, and then the developers, they will debate the choices that the agent made. Or should teams still prescribe architecture upfront before the product designers start communicating with an agent?
So our approach is when the product designer is communicating with the agent, we use ACE. So we give the agent context for how the code base actually works, so it can use that knowledge when it's interacting with the product and create the alignment. If you don't have that, then I would want the product to just create a really in-scope description of the product features and the user behavior they expect. And then when it gets to the actual developer who's about to, let's say, vibe code or vibe engineer, just an important precursor is not take this, implement it, but first take this, let's plan out the architecture together. Okay, me and the LM we're aligned in the architecture, now do the work. So just that small pre-step of don't write code right away, let's make sure we're aligned, is actually really critical.
And do we have to, I'd say a lot of people are going to work there, and your company coined Vibe Engineering. Agents stay aligned with the organization's infrastructure and context. We should feed what's happening, what the ideas, business goals, to populate the context. And what does it look like day to day? Do you have to maintain a context file or preferred stacks? And are those prompts verbose manifestos? So confirm or disapprove. The less we specify how, the better agents leverage hidden opportunities. but only if the agent is steeped in organizational context.
So the way we work is the ACE that we mentioned, the Agentic Context Engine, has a knowledge base that it builds over time. The obvious one that we share is one of them is it takes your code base and it annotates your code base in its knowledge base. So it knows what's where, it knows what to look for. If it's looking for behavior X, it knows to look at this folder and maybe this file and maybe even this function, depends how it annotated. But that's all stuff that we leave in the knowledge base for ACE, and it's something that the agent maintains on its own. And that's what we mentioned hashing in it previously, but it has a way to store the state of the code. If something changes, it knows exactly that something changed and it updates. It literally rereads those files if something changed and creates a new knowledge base. And in that sense, we're preventing you from having to give us all those details. Meaning, I don't even, an obvious example, we're in the front end side first. That's where we decided we're going to create autonomous front end as our first kind of milestone as a company. We don't need you to tell us almost anything. The way the workflow for front end works today in most organizations, a designer or a product decides what he wants the behavior to be. It goes to the designer creates the Figma design, and honestly, that's all we need. The interface today is literally give us a Figma URL. We go there. We have an ACE running on Figma as well that gets all the data from Figma that it needs to understand the design nuances. ACE on the code base goes and finds the UI kit, for example. An organization defines a UI kit in the package JSON. You as a developer, if you do vibe coding in a kind of a traditional sense, the right way to do it is to constantly say, okay, we're using this library, go and implement it with this library. This is all stuff that our agent just picks up on their own. As they do the work, they look at the package JSON if they need to decide what libraries are important. They look at all your component files, they decide what components are appropriate. They do a lot of this work just completely transparently. They even align with the way your coding standards is and how you like to write. For us, they even create mock data so that they can render it. They find your run command, they render, they see if it looks like it to Figma, they do iterations to resolve it and improve it. So all this stuff and this ongoing knowledge and how to work with the code, how to contribute to the code, what parts of the code to reuse, agent maintains on its own and uses as it needs to.